Welcome to the Physics Central. Today we are going to discuss something about elasticity, but before that, please click the subscribe button and hit the notification bell to get updated whenever we post new videos. I am Sir Ed, and let us discuss the elasticity of material. There are times that you are stressed and you feel like the whole world is against you, and it will push you to your limits. And in physics, each material has its own elasticity, and we can measure this elasticity using Hooke's law. Based from Hooke's law, each material has its own measure of elasticity. And elasticity is defined as the ability of matter to return in its original shape after being subjected to a force. Just like, for example, a rubber band has a certain limit of elasticity, a level of elasticity. Therefore, there is an amount of force just enough to break it, and we can ask ourselves just how much force is needed for the rubber band to break apart. The answer to this question is given by the Hooke's law, and the force that we want to know is given by the formula F is equivalent to negative K X, wherein K is actually the spring constant. And this law was formulated by Dr. Robert Hooke in the 1660s. Let us familiarize ourselves with Dr. Robert Hooke. So here is his picture. So he has a lot of contributions both in life and in science. But we are not going to talk about the life and contributions of Dr. Robert Hooke in this video. I'm going to discuss that in a separate video. Now let's go and discuss more about elasticity of the material. There are four types of deformation. One is called the tensile or the elongation process. The next one is compression. The third one is shear or shearing, and the fourth one is called torsion. Each type is caused by a separate type of force. So we are going to discuss the elongation process. The elongation process is actually caused by tensile stress, or by, we pull it apart. Tensile stress can be calculated using the formula F over A, because this is defined as the amount of force applied per unit area, and you can see that the formula is right beside me. So F here is the amount of force, and that must be perpendicular to the area. As I have mentioned, different types of materials have different reactions to stress, just like any other individual. I have my own limit, my wife has her own limit, and you might have your own limits too. But for materials, we call this the Young's modulus. So the Young's modulus can be regarded as the ratio of stress over strain, and it is unique for each individual. And I have here a value of the values of Young's modulus, and you can get this on the table which is available in the internet, and I'm going to paste the description down below so that you will get your own copy. I have mentioned that different types of material has its own level of elasticity, and we can rewrite Hooke's law in its new form. We can do it by considering the fact that an amount of force causes an amount of strain, and getting the ratio will yield the elastic modulus of each material, which is actually pertains to Hooke's law. And I have certain types of material, some here, which shows you that if like for example, this flat bar right behind me is subjected to a certain amount of force, and if they are made up of different kinds of material and you're going to stretch them, and by a same amount of force, they will yield different amount of strain. And this is what Dr. Robert Hooke pertains to. We can now rewrite a new formula for the tensile stress based from Young's modulus and based from the new formed Hooke's law. Alright, so we can just cross multiply it. Okay, stress and strain. Alright, so stress over strain is equivalent to Young's modulus somewhere here. And then once you cross multiply, you will see that we have a new formula. Stress is equivalent to elastic modulus times strain, and then once we plug in the values, we will get, so for the elastic modulus, we have determined static. So we have to substitute that, and then once we plug in the values, stress is equivalent to F over A is equivalent to the product of the Young's modulus times strain. Alright, so based from this formula, we can proceed and calculate the amount of deformation caused by an object or caused by a force to an object, and we can apply it in the problems in the upcoming slides. We can now try the formula that we have just derived to solve this problem. So a 2 meter long, a steel rod which is 2 meters long has a cross-sectional area of 0.3 centimeters squared and is now hung on a fixed support by one end, and then the other end is lying vertically, and there is a 550 kilogram of mass hung on it. Determine the stress and strain and the elongation of the rod caused by the hanged 550 kilogram milling machine. Alright, so identify our target. Our target is stress, next is strain, and then elongation. So the information at hand is we have the value for the original length of the material, we have the value for the cross-sectional area of the material, and we have the value for the mass hung on the other end. And we can also refer to the Young's modulus of this steel rod on the table that I have given earlier. Alright, so all what's left for us is to execute and solve this problem. In solving the problem, we need to analyze it, and we need the formula for the solution, and we have it right here. We can use the formula for stress, F over A, alright, because the amount of force is calculated, and then we can actually get the strain using this formula. Strain is equivalent to tensile stress over Y, or the Young's modulus, and for the elongation, we need this formula. Then let's proceed and see the values. Upon getting all the things that we need, we are ready to proceed to the solution. So for the stress, we have the formula F over A, or the force perpendicular divided by the area. So we can get the amount of force by multiplying 550 kilograms times 9.8 meter per second squared, and that will give us 5,390 newtons, divided by the area, which is 3.0 times 10 to the negative 5 square meters, and it will give us 1.8 times 10 to the 8 pascals. So that is the stress that is being felt by the rod, and this stress will cause strain or elongation. Alright, so we use the formula tensile stress over the Young's modulus. I've told you that there are a table of values for the Young's modulus, and then we have to divide it, and then that is 1.8 times 10 to the 8 pascals divided by 20 times 10 to the 10 pascals, and it will give us 9.0 times 10 to the negative 4. It is unitless. Alright, and then the final task that we are asked to do is to find the elongation, and we can derive that expression using epsilon for the strain is equivalent to delta L over LO, and we are after delta L. So we cross multiply L sub O to the other side, thereby giving us epsilon or the strain times the original length. And we have the original length of the material, and all we have to do is to substitute it, and we will get 1.8 mm. Alright, so there is a change of almost 2 millimeter in the length of the 2 meter rod. So if it so happen that we are going to increase the amount of mass hung on it, it will cause much larger or longer deformations, and that is how stress affects the material. And it is also the same way as stress affects every individual. It brings change to our lives. I hope you guys were able to learn something out of our topic. For more related videos and contents, please subscribe to the Physics Central and click the subscribe button as well to get updated to our newly uploaded content. See you guys!